What if one of the most important discoveries about the universe is not a new planet, a distant galaxy, or an exotic object hidden in deep space? What if it is a pattern? A pattern so subtle that it can only be seen when astronomers examine thousands of galaxies spread across billions of light years. A pattern that, if confirmed, could force scientists to rethink one of the most basic assumptions about the cosmos. For nearly a century, modern cosmology has relied on a simple idea. On the largest scales, the universe should have no preferred direction. No cosmic north. No universal east or west. No hidden axis guiding the motion of everything. This principle is known as isotropy. Imagine floating far beyond every galaxy, looking down on the observable universe. You would expect matter to be distributed roughly evenly in every direction. Individual regions may look different, but averaged across enormous distances, the universe should appear statistically balanced. That assumption has become one of the foundations of our understanding of cosmic evolution. But what if reality is more complicated? Recent observations have encouraged researchers to take a closer look at a puzzling question involving the rotation of distant galaxies. Galaxies are not stationary objects. They spin. Stars orbit their galactic centers, sometimes completing enormous journeys that take hundreds of millions of years. When astronomers observe spiral galaxies, they can often determine whether those systems appear to rotate clockwise or counterclockwise from our perspective. Under normal circumstances, there should be no overall preference. If enough galaxies are observed, the numbers should balance out. Roughly half should appear to rotate one way and half the other. Yet some studies have reported hints of a small imbalance. The effect is subtle. It is not dramatic enough to overturn decades of physics. Many scientists remain skeptical, arguing that observational limitations or data processing techniques could create the appearance of a pattern where none actually exists. That skepticism is important. Science advances through verification, not excitement. Still, the possibility is intriguing enough that researchers continue investigating. Because if future observations confirm a genuine directional preference, the implications could be extraordinary. A universal pattern in galaxy rotations would suggest that something influenced the cosmos on scales far larger than individual galaxies themselves. Instead of being entirely random, certain aspects of cosmic structure may have inherited information from conditions present during the universe's earliest moments. And that is where the mystery becomes truly fascinating. The standard Big Bang model describes how the universe evolved from an extremely hot and dense state approximately 13.8 billion years ago. It successfully explains many observations, including the expansion of space and the existence of the cosmic microwave background radiation. But despite its success, the Big Bang model does not answer every question. For example, what happened before that hot, dense state? Did time itself begin at that moment? Or does the story stretch further back than our current theories can see? Physicists have spent decades searching for answers. One major challenge is the concept of a singularity. When Einstein's equations are pushed to their limits, they suggest that the universe may once have existed in a state of infinite density. However, infinities often signal that a theory has reached the edge of its usefulness. Many researchers suspect that a deeper theory of quantum gravity will eventually replace that mathematical breakdown with a more complete description. Several speculative models attempt to explore what such a description might look like. Among the most intriguing is the idea that black holes could play a far more important role in cosmic evolution than previously imagined. Traditionally, black holes are viewed as endpoints. Matter falls inward, crosses the event horizon, and becomes inaccessible to the outside universe. At the center lies a region where current equations fail to provide clear answers. But some theoretical models propose a different possibility. Instead of collapsing forever toward infinite density, matter inside a black hole could eventually reach conditions where quantum effects become dominant. Under those circumstances, spacetime itself might behave in unexpected ways. Rather than ending in a singularity, the collapse could transform into expansion. From the perspective of an external observer, the black hole would remain a black hole. But within that hidden region, an entirely new expanding universe might emerge. This concept remains highly speculative. There is currently no direct evidence that black holes create universes. Yet the idea continues to attract attention because it offers potential solutions to several long-standing puzzles. If new universes can form inside black holes, then cosmic beginnings may not represent absolute creation from nothing. Instead, they could be transitions between different phases of reality. In this picture, our universe might itself have originated inside a black hole that existed within another cosmos. And if that parent system possessed angular momentum, a tendency to rotate, some traces of that motion could potentially be passed on. Not as an obvious cosmic spin visible everywhere. Rather as a faint statistical preference embedded deep within the structure of the universe. A subtle fingerprint left behind by conditions that existed before our observable history began. This is where the galaxy rotation mystery becomes so intriguing. If future observations continue to reveal directional asymmetries, some researchers may wonder whether those patterns represent echoes of an earlier cosmic state. Not proof. Not confirmation. But clues. Tiny hints that the universe may contain information inherited from processes beyond the reach of conventional cosmology. Of course, extraordinary possibilities require extraordinary caution. Astronomy has a long history of apparent anomalies that later disappeared when better observations became available. Instrumental effects, selection biases, incomplete datasets, and statistical noise can all produce misleading results. That is why scientists continue collecting more data. The goal is not to prove a preferred theory. The goal is to determine whether the pattern is real. If it vanishes, the mystery ends. If it survives, the investigation becomes even more interesting. Fortunately, modern telescopes are providing unprecedented opportunities to test these ideas. Powerful observatories can peer deeper into space than ever before, allowing astronomers to examine galaxies that formed when the universe was still young. Every new observation helps refine our understanding of cosmic history. Sometimes those observations confirm existing theories. Other times they reveal surprises. The greatest discoveries often begin with questions that seem small at first. A tiny discrepancy. A strange measurement. A pattern that refuses to disappear. Many of the most important scientific revolutions started exactly that way. Not with certainty, but with curiosity. Today, we stand in a similar position. The evidence remains incomplete. The debate remains active. And the answers remain unknown. Yet the possibility itself is remarkable. What if the universe carries a memory of events that occurred before the beginning we usually imagine? What if spacetime preserves traces of conditions older than the observable cosmos? What if the Big Bang was not the first chapter, but merely the first chapter we can currently see? No telescope has answered those questions. Not yet. But with every new observation, humanity pushes a little farther into the darkness. And sometimes, hidden within that darkness, we discover clues that transform our understanding of reality itself. Whether the galaxy rotation mystery ultimately proves significant or fades away under closer examination, it serves as a reminder of something important. The universe is still full of unanswered questions. And some of the most profound mysteries may not be waiting in distant objects. They may be hidden in patterns we are only beginning to recognize.